Hello all my JavaScript friends, this is the Virtual Waiter aka Mike Smith, and this video covers our test-driven development on our deck class. If you like this video, make sure you click on the like button below and click on the subscribe button to, obviously, subscribe to this channel. Plus, leave a comment below. I would love to hear from you. Okay, so as always, I'm starting off with a completely blank repository. Now I have done npm init on here to get everything prepared. So the first thing we need to do, since this is TDD, is to install our test suite. And the test suite that I like to install like to use is Cypress. Cypress allows me to do end-to-end testing both at the browser level and at the command prompt level. Now we're not going to worry about the browser level for our deck class here, but eventually we will be doing browser-based games, so that's a good idea to go ahead and get used to using Cypress. So once we get Cypress installed, I will see you on the other side. So that completes the installation of Cypress. Now there is a plugin for Cypress we're going to need to use, and that is a Webpack preprocessor plugin. And we do that because we're going to be importing our card class, and Cypress works very, very well if it has this particular plugin and it's trying to import a card class, or it just dies on you. I found out a number of times. So let's go ahead and get that installed. That is called Cypress Webpack, oops, spell it right, preprocessor. Did I get it right? Well, it'll tell us if I've got it wrong. And I'll see it on the other side. Okay, so that has installed our Cypress. Next thing we want to do is we want to initialize Cypress. Oops, this is Windows, so I can put the other slash. And to initialize Cypress, we run this command. And once we do this will initialize all of our files for our testing purposes, plus initialize Cypress for us. And again, I'll see you on the other side. Okay, once you get this pretty little browser window, that means, hey, we are done with Cypress. We're not going to need this window, so we'll just close that out. That'll get us back to our command prompt. Let's now flip over to our code, our IDE, and we can see here that, there it goes. Took a little bit of a second here. It has installed for us some basic files that we'll be using for our integration. The fixtures is basically if we wanted to be able to mock data or anything like that, and we'll be using that one to mark our cards. Plugins, we're going to be changing that here in a second to be able to include our Webpack preprocessor and support them. I have no clue. I don't remember exactly what it does. One thing I want to do here, first of all, is that this shows you examples of what you can do with specifications. I'm not worried about all of these because I know what I want to do here, so I'm just going to delete these integrations, and we'll be putting our test here within this integration. So the first thing I want to do here is I want to fix this plugin to make sure that we have the correct plugin, or using the correct plugin. This will be using our preprocessor plugin. Yeah, let's just erase that up there. Okay, so this will allow us to do our Webpack preprocessor plugin. And we'll get to the fixtures here in just a second once we start getting into the details of our testing, which in reality we're going to start doing now. Okay, so now that we've got Cypress installed, what's next? Our next thing to do is to go ahead and put in our integration. And our integration is all of our specification files. So basically what I like to do here is I've got the deck. So I'm going to create a directory called deck. Of course, you don't have to do this. Of course, it would help if I spelled it right. Come on. Put E there. Okay. And then what I again like to do is I like to split everything up between methods, properties, and the constructor itself. So what we'll do here is we'll just take these one at a time, and we'll take a look at the constructor itself. So what are the things we're going to want to do with the constructor? Well, the constructors are going to be fairly easy to do here, is that we're going to basically want to call it with a new deck and then give it our parameters. And our parameters within this deck is going to be some sort of ID, which will default to a UUID. And we're going to want to give it an array of cards. And this cards is going to be an array of our cards. Try that again, array of our card. So we're going to be importing our card class, and this is going to be an array. And of course, this ID is a string. I should have put that there first. So that's basically how we're going to want to call this. So our constructor is going to want to be able to test to make sure that we supply an ID or supply some cards, or make sure that the cards are the correct cards and that the ID is correct too, and all that. So I'll pop the code inside here, and I'll see you in just a second. Okay, so here is our test suite that we're going to be using for the constructor. The first thing we want to notice here is that it does say that cards has not been installed. So let's go ahead and install cards here first. It's going to be npm install save virtuoid cards. This is a public repository that I have that you are free, and it's available for you to take a look at and for you to work with. Okay, so that has now installed cards, and I got rid of our little squiggly line here underneath cards. So now our card is ready to go. So what are the tests we're going to be doing here? Well, each it statement basically allows us to test for one thing, and you want to try to keep basically one test per thing to operation or toward behavior you want to do for this deck. So I could have just created one it, just put a whole bunch of different tests within the it, but that's not going to tell me if a certain function fails. So I've split all this up into, how many is that? 7 different, 1, 2, 3, 4, 5, 6, 8 different conditions. First of all, I want to make sure, will it create an actual deck class? I mean, if I just called new, will it create a class that is a deck? That's fairly easy to test here. Should I create a class with 0 cards? So could I create a class that has no cards in it whatsoever? This will be basically passing the cards. This will basically be passing the cards itself. Just notice that's a mistake there. That should be array card. The second one here is I should be able to create a deck class with 0 cards and a deck class with 1 card. Now, why am I testing both 0 and 1? Well, I want to make sure that if I test with 0, that does create an empty array, or if I pass an array of cards, it does actually create the array itself. I don't have to test for 2, 3, 4, 5, 6, or 7, because if 1 works, all the rest of them are going to work. But basically, I want to test for the ones where it's completely empty or there's at least 1. So I want to make sure it does pass an array. So we should throw an exception if the card is not an array. So basically, I want to check make sure if our cards argument is not an array. I want to throw an exception. It should throw an exception if it does not contain instances of cards. So yeah, I could pass an array, but I could pass an array of pretty much anything. But I don't want that. I want just an array of cards. So I'm going to be testing for the presence of each element must have a card, and each element must pass or nothing gets added to the array. It just throws the exception. No big deal there. We should not be able to access cards property at all. And this basically means that I want to be able to hide cards from the from the people who are using it. And why do I want to do that? Well, I don't want people to manipulate the cards. Once you have a deck of cards there, I don't want people to go in there and try to manipulate it in any way, shape, or form. I want to be able to control absolutely whether they can have access to cards or not. And I don't want them to have access to cards because I want to control how it gets accessed. So, I'll be doing things like character counts or be able to add cards or subtract cards or whatever, but I don't want to be able to change the physical array within the class itself. So I want to make sure that they cannot access cards, period. Should create a string ID by default. This is actually create a UUID. Now I can't test for a specific UUID, but it should be able to create a string by default. And if I do specify an ID, it should be able to create the ID itself. So those are the 8 different tests we're going to use for the constructor. And each one of them are very, very easy. We basically construct the deck, and then we do whatever we expect. Like for instance, in this case, we're just expecting whether deck is going to be an instance of deck. For this next test here, we're going to do a new deck, and then we're going to expect a deck dot card count, which means this case we're now saying that we're going to have a property called card count here, which will give us the number of cards. Because remember, they don't have access to these cards. I do, so I've got to give them somebody to at least know how many cards are in the deck. And card count is going to be a property I'm going to create. Notice my ID here has little squiggly line underneath it. It basically says, hey, let's see if hopefully that will show up in the screen here. Unresolved variable card count. Let me check see if that actually shows up on the screen. I'm not sure. Come on, come on. Hey, it does show up on the screen. Cool. So it says unresolved variable card count, which basically says that, you know, I haven't defined card count, which is correct. We've got nothing defined for our classes as of right now, and I'll tell you why here in just a minute. So we created a deck with one card. We're just basically checking to make sure card count is equal to 1. Before we did it to 0, now we do it to 1. Should throw an exception. This is how you basically write an exception within Cypress here. We just do a simple little try catch. And what I've done here, and there might be a better way of doing it, I'm not sure, but this is the way I used to do it. I'm an old dog. It's hard to teach new tricks. Basically, if it ever gets to line 26, that means it did not throw an exception in here. So I'm going to force an assertion error there on not assertion error. I'm going to force it to throw an assertion there at line 26. If it does catch on, I'll make sure it is equal to a type error, which basically means, hey, it wasn't the correct type. It wasn't an array. Same thing here. We're basically going to do the instance of the cards. So I want to make sure that that basically each one of the cards is actually an instance of a card and not something else. In this case, I'm passing instances of string. So again, if it gets to line 35, that means it didn't throw the exception, so I'm going to force it to throw it. And so that should be it there. Okay, should not be able to access the card's property, which is a very simple test, is that we're going to check to make sure, you know, once we say, you know, deck, new deck, if we say deck.cards, it should be undefined. And the rest of these are, the last two here are very simple. I'm just checking to make sure that while returning a string, I can't test what string we return because it's a UUID, which means it's going to be unique each and every single time. And then finally, if I do pass it an ID, I want it to be able to make sure that the ID was actually set. And that takes care of all of the tests for the constructors, for the constructor. Okay, now that we've finished with the constructor, let's take a look at the properties we're going to need for our card class. Now, we're going to be passing it an ID and a cards. The cards is not accessible, so we do know that ID is accessible. But if you take a look at the test we've written here, is that we do have a property called card count. So we're actually going to be taking a look at two different properties for our deck. The ID, which is a unique identifier, and a card count property, which would be the way to tell us how many cards are on the how many cards are in the deck. Now let's think about these two properties here. Once you set an ID, it's bad idea to change it, because once you change that ID, then if you got any references to that ID within your application, you're dead at that point. So we're going to make ID a read-only property. And card count should also be read-only. I mean, for instance, you know, you give a deck 10 cards, and we're going to report back to you that, hey, we got 10 cards. And then if your application says, no, you actually have 11, well, then card count's going to not represent the true count of cards in there. So card count is also going to be read-only. So there are no other properties that we have inside of here. So we know we just have two properties, ID and card count. So within the properties, I'm going to click on New JavaScript and type in id.spec. And I'm going to type in New JavaScript and call that one card count.spec. And these are the specifications we're going to use for each one of these. Now, the card count one, we already know that we are having to, if we go to the constructor, we already know that we are testing it to make sure that it is correct here. So there's no need to retest it to see if it's actually readable. We know it's going to be readable. So in reality, the only thing we really need to test here is just to make absolutely certain that the card count is going to be read-only. So let's paste some code inside here. Let's take a look at that. So again, we should not change the card count. And when we're doing that in a very simple way, we're just going to do a try catch. And this try catch is going to basically make sure that if we do change the property of card count, that it will throw a type error. And type error is what JavaScript will throw if you have made a particular property read only. And that's really all we're going to need to do for card count. ID is pretty much going to be the exact same thing. With ID, we set it from the constructor right here, but we don't want to change it, so it's going to be read only. And we know, we also in the constructor at the bottom here, we know we can reread it. So the only thing left to do is to make sure that it actually is set to read only. So within our ID spec here, we're going to make sure we check to see if we do not change the ID. So we change the ID. If it gets to line 8 here, it's going to, we will force it to have an error. Otherwise, we should expect it to be a type error. And that pretty much gives us everything we have for card count ID. This covers all the properties. Now, we're going to cover the big one, the methods. And the methods are basically how we're going to define the behavior of our deck. What are the things we're going to want our deck to do? And let's go through those one at a time. Okay, so what are the methods or behaviors of our deck? Well, first of all, let's take a look at it from the perspective of the card itself. Now, the card-based class that we're going to be using here has basically 3 different properties: a suit, it has a ranking, and it has a value. And we want to be able to basically parse our particular or filter our particular cards or deck of hands to be able to say, you know, give me all of your cards that represents a certain suit. Give me all your cards that represents a certain value. Give me all your cards that represent a certain rank. So that's one of the first 3 that I know we're going to be needing here. Is we're going to need a routine here for getSuit.spec. We're going to need one for getRank.spec, and we're going to need one for getSuitRankValue.spec. And this will basically, each one of these, I want to be able to return a deck of cards. Now, why a deck of cards? Well, let's think about what a deck really is. A deck is nothing more than a collection of cards. That's it. So you thinking a little bit further past, you know, a deck that you're holding within your hand. Think about a game of poker, and let's say we have 4 people in that game of poker. So we've got the dealer has the deck of cards, and he starts dealing them out to all the different players. Now, in reality, what has happened here is that player number 1 has now a deck of 5 cards. 5-card stud we're playing. Player number 2 has a deck of 5 cards. Player number 3 has a deck of 5 cards. Player number 4, the dealer, has a deck of 5 cards. Plus, you have the actual deck itself. How many decks do you have? You have 5 decks of cards within that game. And in actuality, you have a 6th deck because it's say player 1 says, I don't like 3 of these cards. Give me 3 cards. Those 3 cards he gives to the dealer are going to be put into a discard deck. So then you'll even have a discard deck. That's 6 decks. 2 decks plus the number of players for a total of 6, in this case for 4 players. So if you expand your thinking to the fact that a deck of cards is any number of cards that represents at least 0 cards, I mean, because you can have no cards in your deck. That would mean, you know, like in Uno, you won the game, or Rummy, you won the game, or whatever. If you think of everything as a deck of cards, it's just going to make your life a lot easier when you build your application. You're not going to worry about having collections or anything like that. So each one of these routines here is going to return a deck that specified by a particular rank, a deck specified by a particular suit, or a deck specified by a particular value. So we happen to be on getValue right now. Let's take a look at our getValue spec. So let's bring it on in and take a look and see what it is. Very easily, very quickly, let's just throw this right here. We're going to have we're going to return a deck of cards that are based upon the value, and we should return an empty deck if the value does not match. That's easy enough. Hey, I need this value. Give me a deck of cards. Great. I need this value. Well, I don't have any. I still got to return a deck. It's just going to be an empty deck. Real simple, real quick. So how are we going to test for that? So we're going to want our cards to basically, or our behavior to look like this, or our function or method to look like this. The method is going to say get value, and we're going to pass a value. That's it. That's how the method is going to work. Get value 1, get value 4. So we now know that our method we're going to be designing was going to have the word get value, and we'll pass a value itself. And we're going to be using the card count property to be able to return, or to be able to know how many decks there are. Now, what's the date we're going to get the data from? We're going to get the data from a place called deck cards. And that deck cards is going to be part of a fixture called cards. So let me just roll that in here real quick. Okay, I've now copied cards inside here. So this is all the cards we're going to be using for our test here. It's a whole bunch of different ones here. We're passing suit, rank, and value. We're going to do cards comparison, which we'll worry about that a little bit later. But that gives us the cards thing for the value. So there's our deck cards. We're just going to pass that deck cards into our new deck, and then use the get value to figure out that we actually got a deck and that we got the correct card count. So that takes care of the get value. Get rank is the exact same thing, except that we're testing rank instead of value. Get rank, R1, get rank bad. And how come we know it's R1? Because we're passing R1s, R2s, and R3s into our deck. So that takes care of get rank. How about get suit? Well, guess what? It does the exact same thing. Get suit S1, get suit bad. That will test it that will return based upon the suit matches, and return an empty suit if it does not match. And so this takes care of our get suit, get rank, and get value to take care of the suit, rank, and value. Now, our card actually has two other things in it. It has a get for a particular card, and it has what they call a compare method for being able to compare two cards. And this allows applications to be able to have special purpose comparison methods between two cards. And this is explained in our card video, or a series of card videos. But basically, if you set a object as your value, JavaScript really has no very good way of comparing two objects together. So by giving the developers an application to create what's called a compare method, we're able to compare two cards that have some very complicated values to them. But I'm just not going to be able to say, hey, you know, value equal value. I'm going to have to figure out how to do the compare. So that will be our, so next thing we're going to do here is we're going to take a look at the compare and the get methods. Okay, so the last two we have left there is the get and the compare methods. So let's take a look at the get first. Now, let's think about this for a second. If we have a deck of cards and I say, I want to get the card that, get a deck of cards based, or get a card specifically based upon a card, based upon a certain card, I would say, okay, let's do get the 3 of spades, for example. Well, that's kind of worthless because I already know the card. I don't need to retrieve the card because I already know it. So we're not actually going to implement a get behavior here. What I want to implement is a findCard behavior. And this findCard behavior is going to return to us an index number within the array that specifically matches a card within the deck, and return -1 if that card is not found, just like a regular array function will. So let's do that findCard one first. So that's going to be our method. It's called findCard, and its purpose in life is going to be able to tell us if a particular card is there in the array or not. So let's take a look at those tests that we're going to be working with, because this is a little bit more complicated than before. Is that, first of all, we should be able to find the card. And that's basically, you should return us a number between 0 and a certain number. We should not be able to find the card. That basically means we should get a return of -1. In fact, actually, let's go ahead and expand this test here. Basically, if I do the find card, I should be able to find a particular card that has a value of 0. Now, I am finding card to test, which is located right here. That's S1R11 for suit, rank, and value. So if I go to my cards, my suit, rank, and value is the very first card inside my deck cards. Therefore, that number should be 0 because it returns the index number. It should not return the card, so I'm trying to find just a plain old flat new card. That, of course, doesn't exist in our cards, so it should return a -1. So far, so good. It should throw an exception if the argument is not a card, because we're actually passing a card here, so I want to be able to make sure that if I pass a argument that is not a card, that it will throw a type error exception. Next, I want to find a card using compare, because it's just not enough to find a particular card on its own. We need to also find a card using the compare, because again, with the compare method on a card, we give the application the ability to be able to locate cards based upon a special function. And obviously, if they have the special function, they're not going to be able to use just the regular old find card, because that's going to test for suit, rank, and value. And so if any one of those three is not a primitive value like a string or a number or a boolean, then they're going to use the compare method. So we should be able to also find it using a compare method. And to do that, we're going to pass a second parameter within our findCard. In findCard, if we just pass a single card parameter, then it's going to use the normal searching routines for making sure that suit, rank, and value are all primitive values. But if we pass a compare equals true value as a second parameter, then that's going to tell our code here to say, hey, don't use those things, use the compare method. And so when it does that, I should be able to find a 0. And the same thing with this one, I should not find something to do a -1. Now, what we are doing here is that we're passing, instead of our normal dex card, let me just expand this one up here. Instead of our normal card dex that we have, we are expanding dex cards with compare. And that's what all this is down here. I've written a class that extends our card class, in which I've completed a compare function. Now, I'm just doing something real simple, rinky-dinky simple here, just comparing values, but you can be as complicated as you wish. And so I'm using this card with compare class, and so I now have to have a object, or in this case an array, which has the card with compare class in it and not the regular class. And that will then allow me to be able to use the compare method on our find card. So that's all there really is to the find card here on that one. And so we've tested the find card. Well, we actually got to test the compare method itself too. So let's go ahead and do our specifications for the compare, and let's throw that in there. Oops, I messed up. Sorry about that. What I'm going to do here is, that should have been, I actually used the method on the card there, and that was the wrong thing to do. I need to use the method we're going to use on the deck, and that's going to be getComparison. My bad. So anyway, so let's take a look at the getComparison, and that's actually a fairly easy one too. It works a lot like the deck one. So let's now take a look at the getComparison, and it's very simple. We should get a deck of cards when given the card. We should not get a deck of cards when given the card. We should throw an exception if the argument is not a card. Now, unlike our find card, we don't need to have a second argument that says use the compare method, because we're already using the compare method. So we're passing our dex with compare as our card, since that has the compare method. And then it's just, we're using getComparison as our routine, or as our method, and we're passing an actual card. And this is the card value I'm working with here. And I only care about value because that's what my compare function does. It just only does value. So I'm returning, I expect either a 9, I expect a 0, or I expect to throw an exception if the value is not a card. And that completes basically ways to retrieve all of these cards. Okay, now let's take a look at some of the fun things that you have to do with decks, because we're now able to get all the different decks there. So what are all the different things we're going to do with decks? So what are the other things that you do with a deck? Well, let's think about it for a second. If you have a deck of cards, one of the first things you're going to be able to do is you need to add a card to the deck. That's real simple. So we'll write a routine to be able to add a card to the bottom of the deck. Why the bottom? Because that's what I chose. It's real simple. And also, if you think about it, if you got a deck of cards here, again, if you're playing poker and you're using the same deck as the discard deck, you don't want to put the cards back on top of the deck. Because obviously, the guy says, give me 3 cards, you take 3 cards, put them on top of the deck, and you deal 3 cards out to him, then he's going to get back those same 3 cards. So you usually put the cards on the bottom of the deck and deal off the top of the deck. So we're going to have an add card routine, which is going to add cards to the bottom of the deck. We're going to have a remove card routine, which is going to remove a card from the deck. Now that's going to get a little bit more complicated. We'll cover that in a second. We're going to also, let's see, what else we do with a deck? Well, we add cards, we remove cards. Oh, we got to deal a card. Let's actually put the operation in there for dealing a card from the deck, which is simply a matter of removing a card from one deck and adding a card to another deck. So there we are using our add and remove methods, which we had already explained. So our deal is going to deal from one deck to another. And then finally, we're going to obviously need to shuffle the deck. And that's a very simple little routine that we'll use there. So let's get into it. First, let's take a look at our add method. Okay, so first of all, I'm going to create my add spec. And adding is very simple to the deck. Basically, I want to be able to just simply add a card to the deck. That's what my first test is going to do. And I should throw an exception if the argument is not a card. So the actual routine here will be add method with passing a card. Right there. There's our deck. We're going to add a card to a deck, and we should expect the deck to equal to 1. That's real simple. And of course, with the exception here is that I'm going to make sure that we don't add anything that is not a deck, and that should go ahead and throw it out there. Now, the question comes up here is that do we want to add more than one? Do we want to add an array? And I'm going to say no at this point. Now, I do reserve the right to change my mind at a later point in time with this. But as of right now, I'm just going to do add one. So I'll leave it up to the application. If somebody's going to deal out, again, using the poker thing, 3 cards, I'm just going to do a loop of 3 adds. Or if 2 cards, loop of 2 adds, or anything like that. I'm not going to sit there and say, give me an array of 3, an array of 2, an array of 1, or add an array of 3, array of 2, array of 1. I could change my 9 once we do the applications, but for right now, that's all we're going to do. So that basically will complete the add. We're just going to add 1 card, and we're going to test to make sure that it's a good spec. Okay, so now how about remove? So let's create our remove spec. And let's grab the code in there. Now remove is actually just a little bit more complicated because there's a bunch of different things we want to do with remove. And basically, I've got my 4 different possibilities at the very top here. So let's take a look at each one of them. First of all, I want to be able to remove a card. So if I want to say, I want to remove from this deck the 3 of hearts, for example. Now, of course, if I don't have a 3 of hearts, or if I can't remove the card, I'm going to return null. But if I do remove the card, I want to return the card. And now, a whole operation here is that I'm going to return the single card from the deck, and I'm going to take it out of the deck itself. So that's what the remove card will do. I can also remove an index, and that basically says I want to remove the 3rd card from the left, from the top. I want to remove the 8th card from the top, and so on and so forth. And that allows us to remove a card based upon position. And that's obviously a real simple one. That's just a simple splice operation. Finally, I'm just going to do a remove with no argument. Now, why would I want to do this? Well, this is kind of help facilitating dealing once we get to the deal here. Remember, on a deal, we're going to remove a card. We're going to remove a single card from one deck and add it to another deck. So I thought it would be really easy that if we just had the word remove and nothing else, that automatically assumes it's going to remove the very top card off of the deck and, of course, add it to the other deck. And finally, if we pass the card at the very beginning as if it was the card object, we're also going to be able to pass the compare equals true, just like we did with the find card, to basically remove it based upon the comparison. Because if we say remove card, we're going to need some way to be able to find that card within the deck. And normally we'll use, again, the get suit, get rank, get value, but we don't have those available to us if they're using a specified compare function. So we're going to need to be able to pass a compare state or compared argument at the very end in case we need to use the compare. So that's all there is to it. Let's take a look at the tests themselves. Here are our tests. Should remove a card based upon the card argument. We've already discussed that. And again, we're going to return the card or null. So if we take a look at that, we basically, I've got a special routine called cloning the card deck. So I'm cloning the card deck. I'm remembering the count. I'm going to remove the card that we're going to test. I'm going to first of all find out if the removed card is indeed a card by using the is method on a card, which is a method that's on the card itself to compare, that basically does a suit, rank, and value comparison. And then I'm going to expect the deck card minus my new count to equal to 1, which means that yes, absolutely, I did subtract out 1. The second test is to remove the card based upon the index number. So I go through the whole routine here, but instead now I'm removing it based upon the index number. And so then again, I'm expecting the card to be removed to match what I think it is, which will be this card up here, which is our very first card in our card deck, and that the number has indeed dropped by 1. I'm going to remove the top card based upon no argument. So we have no argument. I'm just going to remove the top card, which basically is exactly the same as this test before, since I'm removing 0. It's basically the same thing as calling remove 0. And in fact, once we get to the code, you'll notice that's all I do is I just say, hey, I'm just going to do the remove 0 card and be done with it. Next, we're going to be able to throw an exception if the specified argument is not a card nor a number. So if we try to remove it, that it ends up not being a number or it ends up not being a card, we just throw an exception. Real easy there. And finally, at the very end here, we're going to turn the null if the card is not been removed. And so by passing a -1, we basically, it's kind of a way to be able to know that we haven't removed, that a card has not been found. Because the idea here is, if you think about the remove function, is that when we try to remove a card, we're going to make a comparison for the card. We're just going to call, the easiest thing to do is just call the findCard method to find the card within the array, and that's going to return a number. So it will return a -1 if it can't be found. So if I pass a -1 to remove, that's basically going to say, hey, I really couldn't find the card. And I just realized I did forget to take a look at the compare function up here. So let's take a look at the compare. So the compare method is the exact same thing. Where is it? And this has got a simple little error here. This should be compare true. Just want to make sure that we got our test correctly. There, I just realized that was an incorrect thing. That doesn't matter. Okay, actually, it does matter. That's why when you go through things like this, you'll find little errors like this. And because of the way I have the compare method work, all my tests had passed. So, hey, there we are. So I've got the remove here, and I'm now doing the compare equals true to say, hey, use the compare function instead of using the regular functions. And because of that, I'm having to pass a deck of cards that have the compare function already available to them. So that's all there is to the remove. So again, remove is a little bit more complicated. We can remove a card, remove an index, remove the very top card, return null if it can't find it, or return the card if it did find it, and decrement the deck by 1. Okay, let's now deal something off the deck. Dealing is going to be really, really simple here. Okay, for the dealing, we're really only looking at 2 tests here. So when I deal, we're going to be able to deal one card off the top of the deck to another card. So to be able to do that, we're going to be passing to our deal method here another deck. And the reason for that is that basically what will happen here is that we'll subtract the top card off of the source deck and add a card to the bottom of the destination deck. And that's what we're testing for right here, is that we're first of all testing to make absolutely certain that our counts, that basically the count for the source deck has gone down by 1, that the count for the destination deck is gone up by 1, and that we're able to find our card in the destination deck by 0. That's really all there is to it. There's really nothing else there. And of course, if the argument past the deck is not a deck, we're going to test to make sure that is there too. So that's really all there is to deal. So deal again is to be able to take the top card off of your deck and send it to, let me put this back up here, send the top card off the deck and send it to the destination deck. And finally, the last thing we're going to do for our deck is to shuffle it. So let's take a look to see what that code looks like. So this is the code. It should shuffle the cards. What else are we going to be able to worry about here? So how do we know the deck is shuffled? I mean, because we don't know the order or anything. Well, the only thing we can really do here is we're going to be passing deck cards as the number of the cards for our deck here. So I've got a routine here called clone of deck cards, which makes an exact, completely separate copy of the clone for deck cards. So the idea here for deck shuffle cards variable is that if the order of the deck shuffle cards is the exact same order of our deck after the shuffle has been done, because we just say shuffle and that's it, then deck is deck not shuffled should be true. If it comes up to be false, because I'm just using the every method here, if it comes up to be false, then that means that every single card within our deck remained the same from the very beginning, which means no shuffling took place. If at least one card changed positions, then it worked. Does that guarantee me to work all the time? No, it does not. In fact, that basically means that I don't know what the number is, but there is actually a tiny little chance that this test could still pass and still not have everything shuffled. Or shuffled, excuse me, it'd be shuffled and everything, you know, not pass. So it's not a perfect routine, but it does do the job for what we need it for. But this basically just kind of does a quick little, you know, gut check to make sure that our deck is indeed shuffled. So that completes all of our tests. Want to see if it runs? Let's see if it runs. Now, of course, it's not going to run. Let's see what happens. Oh, error, no test specified. Aha! One thing we forgot to do was we need to go into our package.json, because remember I did npm init, and this is the default test for npm init. We're going to go to Cypress run. That's going to be our test command. So now we got that. Let's go into here, npm run test. And I'll see you on the other end. Okay, we're all finished up and we got 12 errors. Absolutely nothing passed. Well, what the heck happened? Well, let's take a look and see what kind of message we got here. Webpack compilation error can't resolve deck. Why can't it resolve deck? Because we haven't defined it at all. There's nothing there. No class has been defined. So if nothing has been defined, absolutely everything blows up. There it is, 12 errors right there. So what good is our test? Well, the whole purpose of the test-driven development is you write your test first. I have not written any code for my class whatsoever. I haven't even written the export default class or anything. So of course it bombed out. So the idea here is that once you have your test written and they all have failed, everything has gone red, you write your test until the tests go green. And once they go green, then you do any kind of refactoring to make sure everything is nice and pretty and everything. So the next thing we obviously need to do is to write the class. Well, cliffhanger alert, that's on the very next video. So that completes our video for our test-driven development. If you like this video, please click on the like button below. Click on the subscribe button to subscribe to this channel and leave a comment at the bottom. I'd love to hear from you.